So of course, I know you're going to say, plug it in. Well, we're really talking about polynomials here, right? So when we talk about polynomials, and the limit is when x approaches infinity or negative infinity. I'm looking for my props. I lost my props. Never mind. Okay. So obviously these are too small to mention when x approaches infinity or negative infinity. That's why I'm going to cover it. Doesn't mean that they're not there. I'm just saying when x approaches infinity, these are too small to mention. This is the most powerful at the top. It happens that it's the only one. And this is the most powerful in the denominator, x to the third. So when I imagine that I plug in infinity here, obviously it will be infinity. When I plug in infinity here, or imagine I do, it's infinity. So this is a situation of infinity over infinity. There is hope, okay? Like 0 over 0. Infinity over infinity has hope. I'm not saying there is guarantee. No, I'm saying there is hope. It could exist. Okay, so then I continue. I cannot do anything to the top. So that stays. But the degree in the denominator has nothing to do with the degree in the numerator. Okay? Nothing. The degree in the denominator is 3. I will factor out exactly what I see. I'm not just multiplying or dividing by something. They are different entities, separate entities. So please do not look at the top, just find the degree. And then you will get 1 plus 4 over x squared plus 10 over x cubed. Again, 5 seconds to check this. X cubed times 1, check. X cubed times 4 over x squared, yes, check, 4x. X cubed times 10 over x cubed, yes, check, 10. So this operation is legitimate. Of course, my next step has to be this. 1, I remove 3 x's from here, I remove 3 x's from the top. So now I can apply the limit. First, I will look at this. Where is this going when x approaches infinity? Then I will look at this. Where is this going when x approaches infinity? My infinity is a little bit crooked. So where is this going? Where is this going?
They're both going up.
Okay, so let's refresh our memory on that. Thank you for saying this. So if we have the limit of 1 over x as x approaches infinity, let's take a look at the graph. As x approaches infinity, a number over a big quantity, what will this approach? Just look at this here. As x approaches infinity,
Infinity.
Careful.
Approaches 0. I'm sorry.
Yes, yes. The function values get closer and closer. So as x approaches infinity, the function values get closer and closer, closer and closer to 0. So the same thing with any power. 4, 10, 3, 2, so on and so forth. 1 over. If it's even 10 over, even if it's 100 over, if it's 1,000 over, this is fixed. But this grows and grows and grows, and this is what happens at the end. So then again, where is 4 over x squared or 10 over x cubed going?
It's 0.
Excellent.
0.
Exactly. So now, again, I'm missing my erasers. I don't know what happened to them. Good. So these are gone. What is left from this limit is this top, and what is left from the denominator?
1.
Exactly. So my question now is, as x approaches infinity, where is x squared going? Because x squared over 1 or x squared is the same thing.
would that be infinity?
Absolutely. So it happened that there was no hope in this case. The limit did not exist.
So do we write infinity or DNE?
When do we write DNE?
Okay, when the function are going in opposite directions.
Correct.
Thank you.
Thank you. Good. Okay, here's another. Let's say I want to find the limit. We had this discussion before, let's say of x squared minus 9. And when x approaches 3 from the left. So please remember, on such a limit, you have to find the domain. Must find domain first. Do not plug in and say, oh, it's 0. No. Please, I'm begging you, no. So can anyone tell us how to start this? How do we determine the domain of such a function? What is our starting point? What is
you
the
can't have the negative x squared root.
Perfect, excellent. So I'm just unplugging my device. Okay, so then what do I have to write?
Taking
Well, we
the
know that
inside.
it can't be 3. Oh, sorry.
Go ahead, anyone. So tell me what to write.
X
Wouldn't it
squared minus 9 is greater than or equal to 0.
Please, excellent, thank you, brilliant. Okay, so please do not take 9 to the other side. I've seen it, we talked about it. Please, this is not the way for quadratic inequality. Quadratic inequality, please. So the only thing we have to do is this. I normally show a table to my students on how to study the sign, but this is quadratic, it's not that big of a deal. And if we remember that this is x squared and x squared minus 9, this is the graph. Very easy to see, the function is positive if I pick between negative infinity and negative 3, or if I pick between 3 and infinity. Very simple, it's quadratic. We could be linear, it's even easier. I don't even have to solve that much. So then I know the domain is negative infinity to negative 3, parenthesis, bracket, union bracket, 3 to infinity, parenthesis. So this, it's intentional. It says x from 3 to the left. 3 to the left. What is the answer? Anyone would like to help here?
Is it 0?
That's why we determine the domain. It's 3 from the left.
Wouldn't it be 3 to infinity? No.
So 3 from the left. Does the function exist on 3 from the left?
Would that be no, since
So then what is the answer? Excellent. So then what is the answer? Exactly. Do not fall into that trap. That's why you have to find a domain first. The function doesn't exist between negative 3 and 3. 3 from the left means 2.9. Let's plug in that function 2.9. I'm going to share my screen. Okay, so here's the function. The square root. Where is my square root? Right there. Up. Square root x squared minus 9 Let's plug in 2.9. So without finding the domain, you're going to potentially make an error. So it is absolutely mandatory to find the domain. Because if you don't, you will get into that trap. Okay, enough of this. Other questions? Other limits? Yes. Let me think about one more. So let's say limit as x approaches 3 from the left from 1 over x plus 3. And then limit as x approaches 3 from the left from 1 over x minus 3. So it's the same 3 from the left, but different function. So what will you say here? What is the limit here?
At 1/6.
Done. Very good. What will you say here?
Negative 1/6.
Careful. So 3 from the left doesn't mean negative. 3 from the left means 2.9.
Would not exist, right?
Careful. What is this, first of all?
0.
Yes, this is 0. We know that 1 over 0 can have 3 possibilities. Do not conclude yet. Negative infinity, positive infinity, or DNE. So now please plug in a number close to 3 from the left, like 2.9, and tell me the sign in the denominator. Just the sign.
Negative.
Good. So then, please choose.
DNE.
No, because this is from the left. We said that DNE is like this.
Negative infinity.
Right. So DNE is something like this. This is DNE. I didn't mean that. We didn't calculate the limit from the left and the limit from the right to conclude DNE. We only calculate the limit from one side. Now, let's talk about this. As x approaches 3 from either side of 1 over x minus 3. Here I have 1 over 0 like we just did, but I cannot conclude. I have to wait and calculate the limit as x approaches 3 from the left, and the limit, because this is not from the left or right, this is from either side. I have to show these two steps. X approaches 3 from the right of 1 over x minus 3. If these two are the same, then I write what it is. If these two are not the same, then I have to write DNE. So, can anyone give us this limit? We already have it. Can anyone give us this limit?
1/6.
Careful. It's
Probably no.
it's still 1 over 0.
Positive infinity.
Positive infinity, because this time you're going to plug in 3.1. When you plug in 3.1 from the right of 3, this becomes positive. That's why this is positive. And now, only now, I can conclude here. What is my conclusion?
Doesn't exist.
Absolutely.
DNE.
Yes. Only now I can conclude DNE. Good question. I know it was a long answer, I'm sorry. Okay, can you please upload just this page? Just upload this so I can see it. Making sure that you remember that every time we are asked to find the limit from either side, and I get 1/6 is 1/6, I'm done. But if I get 1/0, 5/0, 10/0, whatever number, not 0/0, not 0/0, a number over 0, then I cannot conclude. I have to wait. I have to determine the limit from the left. I have to determine the limit from the right because I don't know what to put in here. If it happens that these two are the same, I have to write that. I cannot write infinity, DNE, right? And this could happen. If I change this and put power 2, that could happen. Or if I change something else at the top. So they may be the same. If they are the same, I have to write it here. If they're not the same, then I have to write DNE. So please remember this concept. It's very important. Okay, what would you like to work on next?